Alright guys, so this is part 2, and this video is going to be on logarithms. Remember that in the first video we spoke about the laws of indices, and please make sure that you watch the laws of indices video and make sure you understand your laws of indices in order for you to really understand logarithms. Alright, now let's say we have this exponential equation, a to the power of x is equal to b. Well, if that's the case, then log base a of b is equal to x, right here. And please notice how I read this equation. Log base a of b equals x. Okay? So let's label the part of this logarithmic equation. Now, this a right here is called the base. This b is called the argument. And this x right here is called the index. So if you're asked to interpret a logarithmic equation, let's say log base a of b equals x, it simply means that we raise a to the power of x to get b. We raise a to the power of x to get b. Right? So if we're asked log base 3 of 9, if you're asked to evaluate that, I want you to ask yourself this. What power do I raise 3 to get 9? And that value is 2. So log base 3 of 9 would be 2. Alright. Let's talk about converting equations in exponential form to log form and vice versa. Because that's going to be a big thing with logarithms, right? Interpreting them and knowing how to convert from one form to the other. Alright. Now the first example, we have 5 raised to the power of 3 is equal to 125. I want to convert this equation to log form with a base of 5, right? So that's going to be what? That's going to be log base 5 of 125, because 125 is my argument. That is equal to the index, 3, right? I raise 5 to the third power to get 125. Okay, now the next one, 4 raised to the power of 5 is equal to 1024. In log form, this is going to be log base 4 of 1024, and that is equal to 5. What about this one here? All right, my base is 1/5, so log base 1/5 of 1 upon 25 is equal to 2. All right, here I want my base to be 3, so log base 3 of 15 is equal to x. All right, so look at this one here. I have e raised to the power of x is equal to 1. Now there's something special about this e. This e is called Euler's number, right? Euler's number. And it's actually a mathematical constant. I think it's approximately 2.718. Well, it's irrational, so that was just an approximation. Right? So e to the power of x is equal to 1. And I'm going to want my base to be e. So I'm going to have log base e of 1 is equal to x. But there's something special about log base e. Log base e is called a natural logarithm, and we normally use ln to represent a natural logarithm. So this log base e, I'm going to replace with ln. All right? So ln 1 is equal to x. Now I want you to ask yourself this. What is x going to be equal to? Well, e raised to what power is going to give me 1? Remember we said earlier, in our previous video rather, that anything raised to the power of 0 would be 1. So it simply means that e raised to the power of 0 is 1, which implies that x is equal to 0. Alright? So ln 1 is equal to 0. Alright, so what about log base 2 of 10 is equal to x? Let's convert that to exponential form. Again, this is the base, right? This is my argument, and this is my index. So that's going to be 2 raised to the power of x is equal to 10. All right, let's convert ln x is equal to 3 to exponential form. Well, I said that ln was log base e. So that's log base e of x is equal to 3, right? E is my base, 3 is my index. So this is e raised to the power of 3 is equal to x. All right. What if I have log of 100 and I want to evaluate that? Well, I want you guys to take note of this. I am not indicating my base down here, but it's understood that the base is 10 because that's the default base for logarithm. So if you don't see a base indicated, understand that the base is 10, right? So I want you to ask yourself this. 10 raised to what power is going to give me 100? Well, 10 raised to the power of 2. So log of 100 is equal to 2. And if you have to convert it to exponential form, it's going to be 10 squared is equal to 100. And that makes sense. All right? So if I had 10 raised to the power of x is equal to 1,000, and I had to convert this to log form. Well, 10 is my base. So log base 10. Well, of course, we don't write the 10. So that's just going to be log of 1,000 is equal to x, right? And what power should I raise 10 to get 1,000? 3. So it means that log of 1,000 is equal to 3. All right, let's look at one more. Log base 3 of 3. All right, ask yourself this. 3 raised to what power is going to give me 3? Well, 3 raised to the power of 1. So log base 3 of 3 is 1. All right, that should make sense. Let's talk about the properties of logarithms now. Well, you saw an example, which was the last one that we did, where if my argument and my base is the same, the logarithm is going to be equal to 1, right? So log base a of a is equal to 1. And you saw another example of this, right? Log base a of 1 is equal to 0. When we spoke about log base e of 1 being equal to 0. Now let's look at something else here. If I have an equation, log base a of q being equal to log base a of p, it simply means that these two arguments, q and p, are equal in order for this equation to be true. Because I have the same base and the same base here. Right? Just remember that. So if I have an equation log base 3 of 9 is equal to log base 3 of x, it simply means that 9 is equal to x. Right? Or x is equal to 9 rather. That sounds a bit better. Alright. Let's talk about the more complicated laws. Right? And I'm going to start with the product law of logs. It's going to give you a worded interpretation, and also show you the proof. Alright, so you have a better appreciation of these laws. Okay, so the first law here, I have log base a of p times q is equal to log base a of p plus log base a of q. Right? And in words, this simply means that the logarithm of the product of two numbers is equal to the sum of the log of the individual numbers. Right? Okay, so let's run through the proof. Let x be equal to log base a of q. No, let's say p. X is equal to log base a of p. And let y be equal to log base a of q. Okay. Now let's convert this logarithm equation right there into an exponential equation. And we're going to do the same thing with the other one. So here, a is my base, right? X is my index, so I get a raised to the power of x is equal to p. Alright, do the same thing over here. I'm going to get a raised to the power of y is equal to q. Okay. Now, let's find p times q. What's p times q going to be equal to? P times q is going to be equal to a to the x multiplied by a to the y, right? And what did we say about multiplying exponential expressions with the same base? We keep the base and we add the power, right? So it's going to be a raised to the power of x plus y. Now let's convert this exponential equation right here into a logarithmic equation. But I want this guy right here to be one big argument and x plus y to be one big index, right? Of course, you know the base is a. So I'm going to have log base a of p times q is equal to the index x plus y. And what is x? X is log base a of p. And y was log base a of q. So we get log base a of p times q is equal to log base a of p plus log base a of q. Alright, and that's the proof. Okay, let's talk about the quotient law now. Here I have that log base a of p over q is equal to log base a of p minus log base a of q. And it simply means that the logarithm of the quotient of two numbers is equal to the difference of the logarithms of the individual numbers. Right? So now let's run through the proof. I'm going to use the same statements up here, but instead of multiplying p and q, I'm going to divide p and q. Well, I'm going to divide p by q. Right? So p divided by q is equal to a to the x divided by a to the y. Right? A to the x divided by a to the y. And what did we say about dividing exponential expressions where the bases are the same? We keep the base, we subtract the powers. More specifically, we subtract the bottom power from the top power, which means the top power minus the bottom power. So that's going to be x minus y. Right? Now let's convert to log form now. I want this to be my argument. I want this guy right here to be one big index. This is going to be log base a of p over q, all right, one argument, is equal to x minus y. What was x? X was log base a of q, and y was x was log base a of p, log base a of p, and y was log base a of q. That's the proof right there. Okay, on the power law now. Here I have written log base a of p raised to the power of b is equal to b times log base a of p. Right? And in words, this is going to be a bit more complicated. But in words, it simply means that the logarithm of an exponential expression, right? And this is the exponential expression right here, is equal to the index, right? The index of the exponential expression times the logarithm of the base of the exponential expression. Look, this is the base of the exponential expression, right? So the index of the exponential expression, which is b, times the logarithm of the base of the exponential expression, which is p. All right, now let's run through the proof now. Okay. So again, let x be equal to log base a of p. All right. If I convert this logarithmic equation into exponential equation, I get a raised to the power of x is equal to p. Let me just swing this around so that my final result will look a bit better. P is equal to a raised to the power of x. Now, what would happen if I raise p to some power b? I have to do the same thing with the right-hand side, because what we do on one side of the equation, we do the same thing on the other side. Right? So I'm going to raise a to the x to a power b. Now remember, when I have an exponential expression being raised to another power, what do we do with the powers? We multiply them. So p raised to the power of b is equal to a raised to the power of x times b. And now to make my final result more simple, I'm just going to simply switch the x and the b, right? So that's going to be a raised to the power of b times x. All right. Now, let's convert to log form, where p raised to the power of b is one big argument, and b times x is one big index, right? So log base a of p to the power of b is equal to b times x. And what did we say x was? We said x was log base a of p. So log base a of p raised to the power of b is equal to b times log base a of p. That's the proof right there. All right, let's talk about the change of base now. Now we simply use these laws here if I want to express a logarithm, but with a different base, right? Hence the name change of base. Now, the first one is really the most important one, right? Because this second one right here is just a version of this guy. So let's run through the proof. Let's see. Suppose I have an equation, a to the power of x is equal to b, right? If I change this to log form, log base a of b is equal to x, okay? Let's go back to this exponential equation, right? I want to introduce a different base. So I'm going to introduce some other base, c, and c could be any other thing, right? But I'm going to log both sides of this exponential equation using base c, right? So it's going to be log base c of a to the x is equal to log base c of b, right? Now let's look at the left-hand side. Which law can I apply here? I can apply the power law to bring this x right in front there, right? Bring out that x. So I'm going to have x times log base c of a is equal to log base c of b. Now I can divide both sides by log base c of a, and it's going to give me x is equal to log base c of b over log base c of a. And what was x? X was log base a of b. Right? So log base a of b is equal to log base c of b over log base c of a. And that's a change of base. Now the second one, like I said, is simply just a version of the first one. Instead of changing my base to some other base c, I'm simply going to change my base to b. Right? So I'm going to have, instead of c here, I'm going to have b. Right? So log base a of b is equal to log base b of b over log base b of a. And what did we say was log base b of b? Log base b of b is going to be 1. Right? So I'm going to have log base a of b is ultimately equal to 1 over log base b of a. Yes, and that's what we have here. All right. Let's go through some other properties now that you should know. All right. Here I have the log base a of a raised to the power of f of x. Notice that this entire thing here is the argument. All right? And I said that this is equal to f of x. Well, let's prove it. Well, I have log base a of a raised to the power of f of x. We can use the power law to bring down this f of x in front here. So that's equal to f of x times log base a of a. And what did we say was log base a of a? Log base a of a was 1. Right? So I'm going to have log base a of a being raised to the power of f of x being equal to f of x. Okay. There's another property that you should know. A raised to the power of log base A of f of x is equal to f of x. Let's go through the proof. All right. Let y be equal to A raised to the power of log base A of f of x. Right? Now, I'm going to log both sides of this equation where my base is going to be A. Right? So it's going to be log base A of y is equal to log base A of A raised to the power of log base A of f of x. Now, what else can I do? I can now bring down this guy in front of this log using the power law. Right, so I'm going to now have log base A of y is equal to log base A of f of x all times log base A of A. Right, because I brought him down in front. All right, now what is log base A of A? We said that log base A of A was 1. Right, so I'm going to have log base A of y is equal to log base A of f of x. Okay. What do you say y was equal to? We said that y was equal to A raised to the power of log base A of f of x. Right? So if I'm going to replace y, I have to replace it with this guy. It's going to be log base A of A raised to the power of log base A of f of x is equal to log base A of f of x. Alright, now pay attention here. This guy is the argument for my logarithm on the left hand side. And this guy is the argument for my logarithm on the right hand side. What did I say about the arguments, right? For two equal logarithms with the same base, their arguments must be equal in order for them to be equal, right? So it simply means that A raised to the power of log base A of f of x is equal to f of x. And it's proven. Alright, and right down here I have a summary of everything that you should know, all of the laws, and a couple of properties, a couple of additional properties. I zoom out a bit so you can get everything. Yes, and that'll be it for the theory on logarithms. I will cover some practice problems in the next video.